This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class, such as contact information or social media info, for your own security reasons. So in the chat box, let's go ahead, open up our attendance ticket. Link is there, as well as the password. Give me a green check when you have it open and ready to go. Don't fill anything out in it yet. I will be giving you the answers as we go through class, so it just needs to be open and ready to go. Looking good. All right, so waiting on green checks from Alyssa, Andres, Sienna, Charles, Dalen, Demetrius, Haley, and Johnny, Joshua, Kendra, Kevin, and Zoe O. Looking good. All right, again, link is in the chat box along with the password. Perfect, guys. Okay, so just a quick reminder, passwords are only provided in the live class. So if you're not coming to live class, you're not getting your 10% of attendance. So just a reminder, make sure you make coming to class a priority. Plus, we do all of our assignments in class, so it does make your life easier. Here's my contact info. Reminder that you do get 5 attempts on every assignment. So if you ever do poorly on an assignment, just retake it. Make sure you watch the recording and do it with the recording, and you can get a better grade. Okay, so today we are going to work on the Viscosity Lab. It's a super easy lab, so we should definitely start off strong this quarter. I'm actually going to be providing you with all of the data. So basically, I'm answering the hardest question with you. I'm going to be showing you how to make the graph with the data. And so all you have to do is follow the exact same steps, and you'll end up with the exact same result. Smiley face if that makes sense. Okay, so we should definitely start off super strong with our labs. Okay, labs are worth 25%. So if you don't do this one assignment, you lose 25%, which you could do a future lab and get some of that back, but we want to make sure we get all of our labs done. So tomorrow we will have a game day where we can get some extra credit in class. So you'll notice tomorrow you don't actually have an assignment. You'll have an attendance ticket. But if you come, instead of an assignment, we'll just play a game that reviews all of Unit 1. And if you participate, you automatically get extra credit just for being there and doing the game with us. And then Thursday, Friday, we'll be working on Unit 2. So once more, again, today is our first lab report, and I want to remind you it's impossible to pass the class if you're not doing labs and quizzes, okay? So each individual lab, remember there's actually only 5 of them this quarter, which is nice for us because we don't have to do so many labs anymore. But the problem is that means that each individual lab is now worth way more. They used to be worth like 3% of your grade each. Now they're worth 5%, which is actually the same as a single exam. So each lab is a huge grade. They add up to 25% of your grade. You have to make sure you do them correctly, okay? I always provide a video that goes through all the instructions. Smiley faces if you were with me last quarter, if that was helpful, just so the new students can see. It's definitely really easy as long as you just meet me halfway and watch the video and do it with me, okay? So again, labs, super important. And then reminder, make sure you complete STAR 360. Zeros are going to go in for STAR 360 on Friday, so try to get it done before Friday. You can still finish it later. Just know that if you haven't done it by Friday, you're going to lose that. Your grade's going to go down a whole bunch until it gets completed. So try to complete it so that you don't see that grade drop, okay? So we are in Unit 1 talking about matter, energy, and today we're going to take a look at this concept of viscosity, which is a physical property, and we're going to do an easy lab with it, okay? So our objective for today, like most of our labs, we want to be able to design an experiment based on a hypothesis, analyze the data from the experiment by graphing the data. Again, I'm giving you all the data, so it's super easy. And then our specific part for today is we are just looking at the relationship between viscosity and temperature, okay? So quick review. Remember, physical properties don't change the actual chemicals, right? So talking about like smell, freezing, boiling, melting, viscosity, which we'll talk a little bit in a moment what viscosity is, and density, all of these are considered physical properties because even if you measure or you try to change these things, it doesn't actually change the substance's identity. So for example, if I take ice, is it still just water? Tell me in the chat box. If you have ice, is it still H2O? Is it still H2O? 2 hydrogens and an oxygen? Absolutely. So frozen water is still just H2O. Therefore, freezing is physical because it's still the same chemical. Now, on the other hand, remember we learned yesterday, chemical properties do change the actual chemicals, right? So for example, if you take hydrogen gas and oxygen gas and you actually ignite them together, they'll create a really cool explosion, plus it results in water. So you can see the final result is different than the starting, right? Hydrogen and oxygen gases become liquid water. Smiley faces if that makes sense. Okay, so these two things change, become something new, right? You start out with H, you start out with O, and you end up with H2O. Okay, same thing with zinc reacting with hydrochloric acid. So zinc and HCl react together and they result in hydrogen gas. Just hydrogen gas results in H. Okay, so again, we're rearranging things, we're beginning to make new chemicals. Same thing with like acids and bases. How many of you have ever done vinegar and baking soda together? How many of you have ever done vinegar and baking soda together? Tell me in the chat box. Yeah, it's a super fun experiment, right? What does it do? Tell me, what does vinegar and baking soda do? What is the result when we mix vinegar and baking soda? Yeah, exactly. It creates a whole bunch of bubbles and foam, right? We can use it as a fake volcano, right? But if you were to actually take those chemicals and analyze their chemicals afterwards, they would be totally different. So an acid like vinegar, which is acetic acid, and a base like baking soda, which is sodium bicarbonate, okay, afterwards they actually result in water, which is H2O, and they end up with a salt, right? So those things, I don't have the exact chemical for the salt, but the salt and the water end up being totally different than the acid and the base. Smiley faces if that makes sense. So all of these examples are chemical changes because all of them are chemically changing the actual atoms around. Excellent. So that being said, today we're going to focus on one specific physical property. And again, physical meaning that we're not actually changing the substance. It's going to keep on being the same substance, the same compounds, but it might act a little bit different, okay? So viscosity is a fluid's resistance to flow, meaning how difficult it is to move. So if something has high viscosity, it has a high resistance to flowing. How many of you have ever tried to pour honey out of a bottle on a cold day and it doesn't seem to want to move? How many of you guys have ever tried that? Do we know what I'm talking about? Yes, definitely. Yes, okay, so honey has a high viscosity. It flows very, very slowly. It's very resistant to moving, okay? So again, these kind of seem like opposites, right? When we say the word high, we would probably think that it means it flows fast, but it's actually the opposite. High viscosity actually means it flows slowly. Smiley faces if that makes sense. High viscosity is just like saying high resistance, right? So high resistance. Okay, same thing then with water. Water has low viscosity, and as a result, it has very low resistance and it flows very quickly, right? It's very easy to pour water, much easier than to pour honey. Excellent. Okay, so this is number 1 in your attendance ticket, guys. The blank needs to be filled in with the word resistance, exactly as you see it spelled in the red box. You guys have 30 seconds. Green checks when we have number 1 saved. Ready, set, go. Looking good, just waiting on a few more green checks. Annalise, Dalen, Demetrius, Elijah, Gabe, Jacob, Jasmine, Johnny, Josh, Julie, and Zoe O. Green checks, please, if we're good on number 1. Let me know if we have any issues. Again, if you ever have any issues with your attendance ticket, you can always just take a picture, and as long as you've saved the password and you take the picture, you'll be able to finish it later. Okay, so if you're ever having issues, just take a picture, make sure you have the password saved. Cool. All right, guys. So today's question, we're going to take a look at how temperature influences, oh my gosh, that was so loud. We're going to take a look at how temperature influences viscosity. So how does the temperature of a fluid influence how it flows? Okay, so first, what we do in most of our labs is we follow the scientific method, which the scientific method is just how we investigate the world around us. Smiley faces, if you remember this or you've seen it at some point in a different class, right? Most of you I had last quarter, so we definitely beat this to death last quarter. But even if you weren't with me last quarter, you've probably seen this at some point in another class. Awesome. So the scientific method, what we do is we make observations about the world around us. We ask a question about those observations. From there, so for example, we could say, right, we notice that the sky is blue. Our question is, why is the sky blue? And then from there, we can form a hypothesis or an educated guess. Based on our hypothesis, we can perform an experiment. From our experiment, we get some data that we can gather and analyze. And whether or not our data supports or disproves our hypothesis allows us to draw a conclusion, right? If we disprove our hypothesis, that might mean we need to go back and change it. If we support our hypothesis, that means we can communicate that to the broader scientific community. Thumbs up if this makes sense. Again, I know this is a review for many of you from last quarter, but just for my new students, really want to make sure we go over that. Awesome. So for most of our labs, what we do is we literally go through this process together. So let's go ahead and take a look at this. Steps 1 and 2, observation and questions. First off, what are the 5 senses that we use to make observations of the world around us? 5 senses, list them off really quickly in the chat box. Go, go, go. Yes, first one definitely is sight. Absolutely. Keep on going. What's our next one? We can see our ear here. Yes, we can see this is hearing, absolutely. What about this middle one? With our nose, what does that help us to observe? Yes, smell. Mouth, what do we observe with our mouth? Yes, taste. And last but not least, our skin allows us to do what? Yes, touch. Exactly. Now, in a real life experiment, you would probably be using all 5 of these senses. Maybe not taste. A lot of times we don't want to taste our chemicals. In this case, it probably wouldn't be the end of the world because it's honey. But today specifically, when we do the experiment will be a video experiment. So you'll have to make some observations just based on like sight and hearing more so. Okay, but there are some observations that you've made of honey in the past that can still help you make an educated guess about what's going to happen today. Okay, so here's what's going to happen though. I'm going to actually show you a video that has to do with viscosity. We're going to go ahead and watch that, and I want you to make observations while you're watching the video. Smiley faces if you understand what to do. We're going to watch a video. You're going to make some observations about what's happening. Awesome. It's a really, really cool video. It's going to show you, it's going to prove to you that you can actually hear the difference between hot and cold water, which is pretty crazy to think about. So let me go ahead and get that to you a moment. Sorry, my computer is always super slow. Okay. Let's see here. Let me see if I can get it a different way. Sorry, guys. Okay, here we go. It's going to go ahead and be on the whiteboard. Sorry. Here we go. On the whiteboard. Go ahead, give me a green check when you finish watching it.
And while I'm gone, 5 other YouTube creators have lined up some brilliant guest videos for you. We start with science presenter Steve Mould. And when he told me the title of this video, I thought, no, I can't. And then I was wrong. So be nice, be kind. Steve, take it away.
You have a superpower that you're probably not aware of. The ability to hear temperature, or at least the ability to discern between hot and cold water just using your sense of hearing. And this is something we can test. So I'm going to pour hot and cold water from these identical jugs into these identical mugs. And it's your job to figure out which is which. And I'm going to blur the screen as well because there may be some visual cues that would tip you off one way or the other. Okay, here we go. It should have been quite easy to tell which was which. Feel free to pause the video and leave a comment with your guess if you like, but here's the answer. The first pour was cold and the second pour was hot. And the reason they sound different is because of the fact that water is viscous or thick, if you like. And the viscosity of water goes down when you heat it. This is something that's easier to see with a liquid like honey. So warm honey is more runny than cold honey. Whereas with water, it's less visually apparent. But when you pour water, the way it splashes into a cup is affected by the viscosity. And this change in the splashing of the water changes the sound that it makes because of various complex fluid dynamic reasons. What's really interesting is this is knowledge you already had due to a lifetime of hearing cold drinks and hot drinks being made. And like many things, this is something that you knew intuitively, even though it wasn't something you were aware of consciously.
Go subscribe.
All right, green checks, everybody. If we finished. Awesome, awesome, awesome. All right, I'm going to go ahead and switch back over to our whiteboard. So what happened in that video? Wasn't that super cool? Have you ever thought about that you can actually hear the difference between hot and cold water? Pretty amazing, right? Okay, so that being said, guys, what observations could we make about this video? Again, tell me in the chat box, what did we observe? What did we observe? Yeah, I had never thought about it either, definitely. I was like, this is a crazy question. Yeah, so we were taking a look at sound, right? So yeah, we could hear the viscosity, right? We could actually hear the viscosity, specifically, right? The cold one, the cold cup, right, sounded different, or the cold water sounds different from hot water, right? I would almost say like the cold water sounds sharper maybe, and the hot water sounds softer. Does that sound accurate, guys? Is that what you guys observed? Cold water sounded a little bit sharper. Yeah. Sharper, not shaper. Sharper. And the hot water sounded softer. Absolutely. Yeah. But again, guys, the reason that he said that is that because remember, cold water going to be more or less viscous? Is it going to be more or less resistant? Think about cold honey. Is it more or less resistant to flowing? Tell me in the chat box. Cold honey is less resistant? No, I would say it's more resistant, right? So it's cold water, cold honey are actually more viscous. So they have more viscosity, which means that they're like thicker. They're more resistant to moving. Smiley faces if that makes sense. Okay? Which kind of makes sense because it hit the cup harder, right? Which is why it sounded sharper. Now, on the other hand, hot water is much less viscous, has less viscosity, and therefore it's thinner, right? Just like hot honey is going to be thinner and less viscous, okay? So that being said, guys, we're going to turn this into a question, right? So all we're taking a look at today for this is just the relationship between viscosity and temperature. So we're looking at the relationship between temperature and viscosity. Okay, smiley faces if that makes sense. So these are the two first parts of our scientific method. Okay, awesome. Seeing lots of smileys. Great. Okay, perfect. Let's go ahead and keep on going. So that being said, some observations, right? When a fluid like water or honey is heated, it becomes more runny, right? It becomes it becomes less viscous. So our question for today is then, how does temperature, in this case specifically of honey, influence its viscosity? So let's take an educated guess, okay? So we already know a lot of this. So we're going to be proving this to ourselves today in our lab. So if honey is hotter, what do you guys think? Is it going to be more or less viscous, more or less resistant to moving? It's hotter. Yeah, it's definitely going to be less viscous, right? It's going to have less viscosity, which will mean that it is like runnier, right? It's runnier, or it's less resistant to moving. Right? Smiley faces if that makes sense. Honey's hotter, it's less viscous, it's runnier, it's less resistant to moving. Awesome. Now, on the other hand, we could say it the opposite way. So vice versa, if honey is colder, then what happens to its viscosity? If honey is colder, then what happens? right? So hotter, less viscous, colder, what would that one be? Yeah, it's definitely going to slow down. It's going to be more viscous, more viscosity. It's going to be thicker. It's going to be much more resistant to moving. Okay, so that's what we're taking a look at today. So this is our hypothesis for today. And if you guys have the lab open, which I'm sure many of you don't because I haven't actually told you to do that yet, but if you do have the lab open, you'll notice that I've already listed all of these three things for you. Okay, so I've already given you the observation, the question, and today's hypothesis, but I wanted to make sure we went over them together so that they make sense. Okay? So here's what's going to happen. I'm going to go ahead. We're going to go over the questions 1, 2, 3, and 4 of the lab. You're not going to get super long time to work on each one, but if you find that you're typing too slowly, just take a picture. Okay, it's really just question number 1, because remember questions 2 through 4, I actually give you a video for. Smiley faces though, guys, if that makes sense. I'm going to give you the link to the lab so that you can go ahead, open that up, and have it open and ready to go. Okay, if you're somebody where having 2 assignments open at once slows down your computer, we're not going to do the rest of the attendance quiz until the attendance ticket until the end of class. So if you want to kind of close that one, as long as everything's saved and just open up the lab instead, that's totally fine. Okay, so specifically talking to Ariana, I think. Cool. All right, guys. So yeah, we're in the Unit 1, the 1C lab. So have that open. Give me a green check if you have your lab open. You'll see there's 4 questions. It's pretty short. It's going to be super easy because, again, I'm giving you all of the data today. Yeah, Ariana, that totally works too. You can take pictures and finish it later, as always. Totally, totally. Cool. All right, guys. So again, here's our hypothesis. Temperature is hotter, then it's going to have lower viscosity. It's going to be runnier. Or vice versa, if temperature is colder, it's going to have higher viscosity. It's going to be thicker. Okay, so let's take a look at what our independent variable and dependent variable are in this experiment. So for those of you that weren't with us last quarter, an independent variable in an experiment is whatever we change on purpose at the start of the experiment. The dependent variable, on the other hand, is the data that we measure at the end of the experiment. It's the result or the effect, right? Cause and effect. Smiley faces if that makes sense, everyone. Again, just going over this a little bit more in depth because I do know we have some new students. Awesome. Okay, so that being said, guys, whenever we take a look at our hypothesis, the starting part helps us figure out what our independent variable is. So take a look at the beginning of our hypothesis. What are we changing on purpose in our experiment? What are we changing at the start? What is our independent variable? Yes, absolutely. We're going to be changing the temperature of the honey, right? Thumbs up if that makes sense, everyone. The temperature of the honey, specifically in this experiment, is our independent variable. Excellent. Now, our dependent variable comes from the second part of our hypothesis, the then part. So in this case, what are we looking at the end of the experiment? What's the result that we're trying to take a look at? Take a look at the second part of our hypothesis here. Yeah, we're taking a look at viscosity, or exactly, Sarah, we're taking a look at how well the honey flows. So viscosity or flow of the honey. Okay, that's going to be the dependent variable in this specific experiment. Okay, so both of these things right here are the answers to number 1. In this case, you are allowed to copy these word for word. Okay, most questions I don't allow you to copy, but in this case, these are the answers, so you can definitely fill these in as you see them for number 1. So here's the deal, guys. Again, you have 60 seconds to either type these and save them in number 1 and give me a green check, or if you're a slow typer, you can take a picture and give me a green check. But I need green checks all around, so you guys have 60 seconds. Ready, set, go. All right, just waiting on a few more green checks, letting me know that you have filled out number 1 in your lab report. All right, so waiting on Adriana, Angelina, Annalise, Chanel, Ciara, Dalen, Demetrius, Destiny, Edgar, Elijah, Gabe, Jacob, Jackie, Jasmine, Tucker, Josh, Seha, Stephen, Ty, Zoe. Oh, green checks all around, please. Melissa, you as well. For number 1, again, you can copy the purple words word for word. For number 1, that's totally fine. Just be aware that I don't say that for every question. Just number 1 you can copy. Awesome, guys. All right, so that being said, today's lab is super easy. It's actually a video lab, which means you're just going to watch a video of how this lab was done, and I will be providing all of the data to you. Smiley faces if that makes sense. Okay, so today you don't actually have to do any virtual lab stuff. It's super, super easy. Yeah, so I'm going to go ahead. I'm going to give you the video to watch the experiment. Let me go ahead. I'm going to see really quickly how long it is. It's not super long, guys. It's like maybe 2 minutes, I think. Sorry, hold on. Where is my link here? Yeah, it's super short, guys. Okay, so I'm going to go ahead. I'm going to put it on the whiteboard. I'll also put it in the chat box in case your whiteboard isn't working correctly. But go ahead, watch that video of how this lab was done, and then give me a green check when you finish watching it. Okay? All right.
Hi, I'm Pat Keeney, an instructional designer with K-12. Along with my assistant, we're here to work with you on a lab that explores the viscosity of honey. In most lab work, advanced preparation is needed and safety is always important to consider. Viscosity is a fluid's resistance to flow, while substances, such as honey, are described as being viscous. All fluids can be characterized by their viscosity. Molasses, motor oil, and honey all have high viscosity. Water, juice, and rubbing alcohol all have low viscosity. In this lab, you will see how viscosity responds to temperature. The important question to consider in this lab is, how does viscosity change with temperature? Viscosity indicates the thickness of a fluid. Specifically, viscosity is a fluid's resistance to flow. In this experiment, we will warm up cold honey and then measure how it flows down a ramp to demonstrate how temperature and viscosity are related. Use your observations and prior knowledge to write a hypothesis that describes how viscosity changes when temperature changes. A good hypothesis should take the form of an if-then statement, such as, if the temperature increases, then, well, you finish the rest. Honey packets can be made in advance by putting 1 tablespoon of honey in 7 snack-size, zipper-closed plastic bags. Or you may obtain honey packets in a cafeteria or restaurant. Freeze the honey packets for several hours. We made a tray of ice cubes, which was needed to lower water temperature during the experiment. Before beginning the lab, we will create a data table with the following columns: temperature in degrees Celsius and distance covered in 30 seconds, measured in centimeters. We'll get our ramp ready by placing aluminum foil under one end of a cookie sheet to catch any spills. First, we tape a metric ruler to a cookie sheet lengthwise, with the 30-centimeter end near the bottom of the sheet. Then we add a piece of tape to create an easily visible reference point as a starting line. Now we're ready to get started. We put a thermometer in a large plastic container and then filled the container with water that was about 70 degrees Celsius, slightly colder than what is needed for hot tea. We then recorded the water temperature in the data table. We were concerned about some safety issues. For instance, if the water is too hot, it would melt the plastic honey packets. Never microwave honey packets. They will heat up extremely fast and the microwaves weaken the plastic. The packets may break when you handle them. Hot honey can cause bad burns because it sticks to your skin. To warm the honey, we placed a honey packet in the water for 5 minutes and then removed the packet. To get the best lab results, we sealed the packet securely before placing it in the water and dried the packet when we removed it from the water. This avoids mixing any water with the honey. Water may alter the viscosity of the honey and therefore could compromise the experiment. Next, we removed the packet from the water, dried it, and then used scissors to snip off the corner of the packet. With the cookie sheet flat on the work surface, honey was squeezed onto the sheet near the 0-centimeter end of the ruler. We lifted one end of the cookie sheet off the table and onto the container so that it was angled, allowing the honey to flow down the sheet toward the 30-centimeter end of the ruler. To get the best lab results, understand that certain things may vary, such as the honey itself, the indoor temperature, or even the type of cookie sheet. In the first trial, if the honey moves too fast or too slowly, we could increase or decrease the time of the trial, or tilt the cookie sheet more or less. After the first trial, we have to be sure to always use the same setup for each succeeding trial. Notice that we were certain to wipe all the honey from the cookie sheet. We repeated the entire procedure using water at approximately 40 degrees Celsius to warm the honey. Then again using room temperature water at about 20 degrees Celsius, and in ice cold water at approximately 0 degrees Celsius. We used ice to lower the temperature of the water. You probably understood before beginning this lab how viscosity is related to temperature. Now that you have seen this lab conducted, you should be able to describe that relationship. You will be provided with data from this experiment and possibly others like it. In all cases, the same procedure has been used.
Green checks, please. Awesome, guys. All right, I'm going to go ahead and switch back over to our whiteboard. But what you guys can see here is that for this experiment, what happened was they heated up honey to a certain temperature, and then on that tray, they took a look at how far of a distance it could move based on that temperature, right? And what you'll notice is the further it flows, right, the less viscous it is, right? The less resistant it is to flowing. Smiley faces if that makes sense. That's how we are measuring viscosity, is based on how far it flows, okay? Awesome. So again, we had our hypothesis, and this is the data that we collected based on this hypothesis. Now, again, I am providing this data for you. So in this instance, you are allowed to, and you are supposed to copy this exact data that you see up here. It's also in question number 2 of your lab. Smiley faces if you see that data table in question 2 of your lab. Okay, all of that data is provided to you. It's a super, super easy lab, guys. Okay. Awesome. So that being said, what's going to happen is I'm going to give you a video with instructions on how to graph the data. Okay, so this is the hardest part, guys, but the video gives you step-by-step instructions, and it's super easy as long as after each step you pause the video and do that step. Okay, thumbs up if we understand. So you're going to watch, pause, do the step, and then play. Watch, pause, do the step, play. Watch, pause, do the step, play. Yeah. So yes, you'll notice, as Mikey stated, that we do need to use Google. Okay, so if you don't already have a Google account, you do need to make sure that you make one. Yeah, the alternative, guys, is that you would have to download a document, you'd have to draw it out, and then you would have to scan it and re-upload it, which a lot of people don't have those tools, which is why we do the Google account instead, because everybody can do Google. Okay, so here's what, if you don't have a Google account, please make sure you take 30 seconds to make one. I do include those instructions in the video, so don't worry, you can do it a little bit later, but I do want to emphasize, if you don't make a Google account, you won't be able to do the labs, and again, you're going to lose out on 25% of your grade. So smiley faces if we understand. Make sure we do this. Yeah, it is Google Sheets, so it's more like Excel instead of like Word. Absolutely. Awesome. So again, the video is going to teach you exactly what you need to do. Unfortunately, we're almost out of time. So instead of just having you watch it for like a minute, I'm going to go ahead and just give you the link to it. And you guys can go ahead and open that up. And then you guys can go ahead and work on the lab. This is going to answer questions 2, 3, and 4 for you. And again, guys, because I'm giving you all of the data, I'm actually giving you the answer to number 2 in your lab report. Okay, smiley faces if that makes sense. I'm actually giving you an entire answer. It's super, super easy. Okay, this is going to be the easiest lab Awesome. Okay, guys. So the video is there for you in the chat box. Make sure you watch it, open it so that you have it saved for your lab report. It'll also be included in this recording. But if you want to start working on it right away, I would definitely save that link right now. Okay? Okay, students, so at this point we have already answered question 1 in our lab. Remember, we should have watched the beginning of the recording of the class to answer question number 1. So now we're going to go ahead and work on questions 2, 3, and 4 in this video. And this video is going to give you instructions step by step. So after each step, make sure you pause the video and complete that step in your own lab report. If you don't pause frequently, it does get confusing. So remember, watch a step, pause, and then continue on once you have completed that step. So the first thing is you do need a Google account. If you don't already have a Google account, it takes about 30 seconds to make one. So just go to accounts.google.com/signup, enter that information, and remember to save your username and password because we will be using our Google account for all of our labs this quarter. So really important that you have that, otherwise you will not be able to do your labs, and that means that you will automatically lose 25% from your grade. So it's a huge grade. So that being said, guys, once you have your Google account, make sure you're logged in, and then you need to go to docs.google.com/spreadsheets. So I'm going to go ahead and open that up, docs.google.com/spreadsheets. And that is going to take me to where I will be entering my data for this lab report. Okay, so there's a summary of instructions here. So we're going to be creating a sheet, titling it, entering our data, which our data is provided for you. I'll show that to you in a moment. We're going to highlight all the data and insert a graph, making sure that we change it to a scatter plot. From there, we'll edit some titles and we'll add a trend line, make sure that we can see our trend line fully, and then we'll copy and paste the shareable link into our lab report. So that's where we're going currently. Again, I will show that to you in a moment. Okay, so the first thing is question number 2 actually gives us our data. Remember that in this lab, I actually do provide the data for you. You watched a video earlier in class that showed you how the experiment was done, but now we actually do have our data, right? So we're taking a look at the temperature of honey and the viscosity, or how far it can run, right, if it's runny, when at different temperatures. Okay, so we are copying this data exactly as provided. In this instance, you do copy everything in this graph, okay? So most of our labs, we don't do any copying, but in this time, I'm giving you permission to copy this. You absolutely need to make sure you copy it. So this is the same data that you can see in question number 2, so I'm just going to go ahead and minimize this right now, just so I don't have as much stuff on my screen. So here we go, step by step. First, we're at docs.google.com/spreadsheets. We need to click the plus sign right above where it says blank, and that's going to start a new spreadsheet for us. Okay, so here's my new spreadsheet, and the first thing I need to do is I need to retitle it. Okay, so I'm going to go ahead and, sorry guys, I'm going to go ahead and title it right here as the Viscosity Lab, and then you need to make sure that you type your name here. Okay, it makes it much easier to grade. If I don't know whose lab it is, it makes it more difficult for me to grade, which means that you're at risk for not getting points. So make sure you type your name. So in this case, I would type Mrs. Larkin, for example. Okay. Perfect. Okay, so now we're going to go ahead and enter our data right here. So the first thing is we need to title our columns. So in column A, the title right here is temperature in degrees Celsius. So I'm going to just type out the word degrees Celsius. Degrees Celsius. Okay, and just so you know, right, if this is covering up, if column B is covering up column A, you can actually just click and drag the column bar up here, and that will spread it out so that you can see everything. And then the second column needs to be what's written right here, which is going to be distance covered in 30 seconds, parentheses, centimeters, cm. And again, you can drag this out of the way so that you can see the entire column. Okay, so that's the title of our data right here. Now I need to fill in these numbers. And again, in this instance, it's totally fine for you to copy this data. You should be copying this data, okay? So temperature, right, 70.0, 40.0, 20.0, 10.0, 0.0. Okay, really important here, please make sure that you don't put any letters next to these numbers. It should only be numbers by themselves. So we already included that this is in degrees Celsius in the title here, so we don't need to include it here too. It should just be numbers. If it's not numbers, your graph won't work and you will get a 0 on your graph because your graph won't work. Okay, now over here under distance covered, I'm going to enter the data I see right here. So 7.2, 6.1, 5.3, 4.7, and 4.4. Okay, again, make sure you pause the video, make sure you complete this step right here. So once we have our data all in here, okay, I'm going to go ahead and actually click where it says temperature, and then while I'm holding my mouse, I'm going to actually drag it down so that I highlight all the way from temperature down to 4.4. So again, all you need to do is you click and holding it down, drag it to highlight the entire table, titles, and all the numbers. From here, we're going to click where it says insert, and then we'll click the word chart. Okay, and I'm going to go ahead and expand this a little bit just so that we can see everything. We don't really need this right now, so don't worry about that. For now, I'm just going to expand this. Okay, so the first thing that I can see here is that this is currently a bar graph, which is not the type of graph that I want. So where it says over here column chart, I'm going to click on that. And scrolling down, you're going to see where it says scatter. Click on the first option. So this first option right here, just the plain scatter chart. Okay, and now I can see some dots here, and the dots are what I want to see. Okay, perfect. So from here, all we need to do is we're going to customize some of the information here. Really quickly, guys, if you do click outside of your graph, you'll notice that this menu does disappear. It's totally fine. Just double click on your graph again, and it will pop up once more. So again, we've changed it to scatter chart. Now underneath customize, click there. And we're going to go ahead and fix the titles. Okay, so chart and axis titles. So the chart title should just be distance covered versus, versus temperature. Okay, so we can simplify that title. So distance covered versus temperature. Super easy. Double check that your other axes are correct. So if you click where it says chart title and change it to horizontal, you should see it says temperature degrees Celsius. That's correct. And if you click it again and look at vertical, it should say distance covered in 30 seconds in centimeters. Please make sure that you do have these units, the parts that are in those parentheses. If you don't have that, you do get 0 points on the titles. So make sure that you include the units so that you get full points on your titles. Excellent. Okay, so the next thing that we need to do is there's always this funny option that gets clicked underneath horizontal axis. So we're going to click on horizontal axis, and where it says treat labels at text, we actually want to change this. So we're going to uncheck this. Okay, so now you'll see that some bars pop up here, and that's correct. That's what this should look like. So you should have bars both going left and right, and you should have lines going up and down. Okay, so now that looks correct. So the next thing that we need to do is we need to add a trend line to this. So the way we're going to add, and you'll notice that the data flipped, which again, that is correct. Okay, so we again should see our data flip, and we should see these lines pop up. Okay, so now we're going to go up to where it says series, and we're going to click trend line to add a trend line. So now we have a trend line on our data here. Okay, and this is going to help us make a prediction when we talk about question number 4 a little bit later. So that's why the trend line is important. So the last thing is we do need to be able to see a little bit more of the graph. So what we're going to do is we're going to go down to grid lines. And underneath vertical axis, we're going to change the word auto, major grid line count auto. Click on auto and change it to 10. Okay. Underneath minor grid line, you're going to want to change this number from none to 4. Okay, and all this does is if you increase this, it allows me to see the numbers a little bit better, right? I can see that this is 7, 7.1, 7.2, 7.3, 7.4, 7.5. So it allows me to see these little numbers on my graph, which is going to be important again for question number 4. I also do need to fix the horizontal axis, so click where it says vertical and change it to horizontal. And the only thing you need to change here is you just need to change where it says auto to 10. Okay, and now this looks exactly like we need it to look. So your graph and your data should look exactly like mine up here. I just did it step by step for you, so you should get full points on this. Super easy as long as you follow the instructions. I gave you the answer. This is literally the answer. Okay, so that being said, once we have our graph done, all we need to do is we need to include it in our lab report. Okay, please make sure that your graph is nice and big so I can see it really well. And please also make sure that you move it so that's not covering up your data. So move it out of the way. Okay. So that being said, what we're going to do is we are going to, underneath question 2, we need to provide the shareable link, and it has to be the shareable link. It cannot be this link up here. If you give me this link up here, you will get a 0 on your lab, on this question, which is 9 points, most of your lab, because I can't actually see your graph. So instead, you need to go to where it says share, again, the shareable link. So we're going to click share. And then right here it says get shareable link. So we'll click get shareable link. And now we have a link right here that we can copy. So click copy link. So again, share, get shareable link, copy link. From here, we're going to go right here and we are going to paste this. So we can right click and paste. If you are using a PC, you can also type, press both Control and V at the same time. That'll do the same thing. Or if you're on a Mac, you can press Command and V at the same time, and that will both paste it in here. Okay, so we need to make sure we copy and paste this here. The end of your link should say sharing. If the end of your link does not say sharing, it means I won't be able to see it. It means you gave me the wrong link, and it means you will get a 0 on this question. So make sure the end of your link says sharing. Perfect. Okay. So that is question number 2. Moving on to question number 3. Number 3 is just our conclusion. Okay, so this is just figuring out whether or not we are correct on our hypothesis. Okay, so I'm going to go ahead and minimize this right here and go back to these instructions. Okay, so when we analyze data, we use that data to determine if it supports or disproves our hypothesis. So remember, our hypothesis was if temperature is hotter, then it has lower viscosity, it's runnier. Or vice versa, you could say if temperature is colder, then it has higher viscosity, it's thicker, right? So we're going to take a look at our data and figure out, did we support or did we disprove our hypothesis? So looking back at our data here, okay, what we can see is we can see that at higher temperatures, right, the distance that it covered was much further, right, which means that it was runnier, right, it had lower viscosity, and so it went much further. Okay, same thing with the other part of our hypothesis, right, the vice versa. At colder temperatures, over here on the left, we can see the distance covered was not very far, and therefore it was much thicker, it was less runny, it had higher viscosity. So taking a look at my data here, my data definitely does seem to support this. So in this case, I would say that my hypothesis was supported. Okay? Now, that's great and everything, but if you only do this first part, you do get a 0 on this question. You need to both include that it was supported as well as give me actual numbers from this data table telling me why this was supported. So the way that you would do this is, for example, or my results prove this because, for example, at a high temperature, higher temperature like, okay, insert a temperature, right? Insert one of these higher temperatures, right? The honey traveled further at blank centimeters, right? So again, insert the distance it covered. At lower temperatures, like, again, choose one of the lower temperatures, the honey only traveled at, tell me what distance it traveled at, blank centimeters. Okay, this shows that at higher temperatures, it is, tell me, is it runnier or thicker? Okay, which means it has, which means it is less viscous, or it has, let's say it has less viscosity or more viscosity. Okay, and again, runnier actually means less viscosity. Thicker actually means more viscosity. Remember, those are kind of opposite. Runnier is less viscous, thicker is more viscous. Okay, so whichever one you choose, if you choose the first one, runnier, then you should also choose less viscous. If you choose thicker, you should also choose more viscous. Okay, so again, you need to go ahead, fill this in. You can use this exact exact template. As long as you insert your own numbers and you choose the correct words here, it'll be in your own words and it won't be copying. I'm really big on not copying word for word just because that's plagiarism, but in this case you can totally use this template. Just make sure you fill in the numbers correctly and fill in your conclusion here correctly, and that'll be totally fine. Okay, so that's question number 3, super easy. The very last question, question number 4, asks us to use the trend line. Please don't just guess, please actually use your trend line, and we're going to predict how far the honey flows at 80 degrees Celsius. So I'll show you exactly how to do this. Okay, so I'm going to go ahead and copy this really quickly so I can draw on it. Okay, so here we go. So if I want to see how far, again, honey will flow at, what did I say? 80 degrees Celsius, I need to find my temperature of 80 degrees Celsius, which in this case is right here. Again, we fixed the grid lines here so that we could see 80 degrees Celsius. That's why it was important to fix the grid lines. So what I do is I start at 80 degrees Celsius and I go straight up until I hit the blue trend line. Again, we have to use the trend line. That's why the trend line is important. Once we hit that blue trend line, we're going to go ahead and now look over to the distance that it covers at that point. So just go from here and look straight to the left and figure out what distance would that be. Okay, so again, I had you change the grid lines so that you could see what numbers these are. So it looks like it's somewhere between 7.6 and 7.7. So you should be able to guess what the correct number is. So look right here and choose a number that seems accurate between 7.6 and 7.7. And that should be our answer here. Okay, and again, please make sure you include units. So in this case, the units would be centimeters. Oops, centimeters. Okay, and that's all you have to do. At this point, you can go ahead and you can just submit your quiz and you are all set. So you'll submit your quiz. It's actually a lab, but make sure you submit. And it's going to ask you again, make sure you click it twice so that's actually submitted. And that's all you've got to do, and you will have a lab completely done. Thanks so much, guys, and I will talk to you later. So that being said, guys, I'm going to go ahead and actually finish us up here. So just make sure you have that video. It's going to do 2, 3, and 4 with you. The lab is due at 4 o'clock, but I find it much more important that you do it correctly. So just turn it in when you finish it correctly. Okay, so if that's past 4 o'clock, not a big deal. You'll still get full credit. So I just don't want you to turn it in blank or something because that's stupid. A, I give you all the answers, and B, it's just not necessary. It's super easy as long as you watch the video. Okay? Are there any questions? Tell me in the chat box. Any questions about that? Again, if you're a new student, it might not make total sense yet, but watch the video. The video helps you quite a bit. Perfect. Cool, guys. All right, so that being said, here's your last word, and I will see you all later. Thanks so much, everyone, and I'll see you later. Bye-bye.